Let's go through C string here. Remember here, we're not talking about C++ string, okay? C++ string is actually a class. The C string that we're talking about here is a collection or an array of characters. So let's define what a character is. Let's say char C, right? So in order to declare, right, a character and initialize it with a variable, we use what's called the single quote right here, right? So this is what we call apostrophe. However, if we write this, right, and this is an array notations here, and with use of a double quote, in this case, this double quote represent a collection, right, or an array of character. In this case, this array only has one element in it. However, remember C string, right, terminates with a 0, right? So there is a 0 or null, what we call null terminator here. This is null terminator, right? And this is where A is. That's what happens, right? This is what we call C string, and this is 2 bytes. Why? Because the very first A, right, this character occupies 1 byte, and the null terminator itself occupies 1 byte. So this is total 2 bytes. This C, right, is a char. So this is only 1 byte. So let's look at some of the examples in code. Let's write char C here, right? And this is our single characters. And you would print this, right? Specifier that we need to use is %C, right? And this gives us the value of that characters we have here. Now, if we turn this into a double quote, and remember a double quote is a C string, so we must use the array notations here. And because this is a C string, we're going to print using the format specifier %s, right? So this gives us that. The difference between the two is obviously C string is a lot more bloated, right, than a character itself, because C string is an array with a null terminator at the end. And let's make this much longer. Let's just say ABC. A C string terminates with a 0. So what we can do is we can modify our C string by making it shorter. And the way to do that is introduce a 0. Let's say we introduce a 0 at C, right? So replacing C with 0. So if we say this equals, right, 0, alternatively, we can write this, right? Remember using the escape characters. This introduces a 0 at this location. And if we to print this now, right, notice that we get A and B. And the reason is because when we have a C string terminated by 0, at this point, your printf is not going to keep reading past that 0. In that case, it'll give you A and B instead. Just be careful that we don't just throw a 0 by modifying a character inside a C string, making it a lot shorter than it was before. If this is done unintentionally, you introduce a bug. So now let's look at the number of bytes. Now we know this character A, B, and C occupies a total of 3 bytes, but because there is a null terminator which occupies another byte, when we do a size of, right? And remember when we do a size of, right, on an instance, it gives us the size or number of bytes this instance is. So in this case, this instance is a C string. So because this returns an integer, actually onside long in, so we want to use LD in this case as a format specifier, and let's print this. This gives a total of 4 because A, B, and C occupies 3 plus 1 null terminator. It gives a total of 4. Now, if we change this back, right, to a single quote, remember using a single quote, you can only have A in it, B in it, or C in it, but you cannot have multiple elements in it. This simply does not exist. This won't even compile. So if we do this and do a size of, again, we should be getting 1. And the reason is because a character itself is not a C string, so there's no null terminator. So this gives us that. Now let's do another exercise involving the number of characters inside a C string. We must understand there are string handling routines or functions in the C standard library. And one of the libraries that we have is called string.h. Now, in C++, there's pound include string, right? There's also pound include C string, right? Without the .h in it. But those are C++ libraries, so do not get confused with those. Now let's introduce this thing called strlen. This is another routine that calculates the number of characters inside of a C string. So in this case, we have to convert that into a C string. Let's go back to the ABC examples again. So in this case, we use double quote ABC. So this function strlen gives this number of characters, excluding null terminator. Okay, so that's the difference between size of and strlen. Strlen does not include a null terminator. There are many more useful routines for manipulating these null terminator strings in string.h library here. In fact, there are libraries for copying string, concatenating strings, getting the length of strings, comparing strings, etc. So let me just illustrate a few of them. So besides the strlen, there's also the comparing of the two string. So this is string comparison that takes two string instances, for example, and returns whether they're equal or not, right? You'll have to use a special string handling functions like this to test the equality of the two strings. So this is what we call like deep comparisons, comparing each element against each other. And how do you know how this function works? Typically, we'll go to, API documentation. So there's a very nice Wikipedia chapter on C string handling sections, or sometimes you can go to c++.com, the authoritative online resource on all C, C++. You'll find API documentations on string.h. There's a whole bunch of them out there. So strcom in general returns 0 if S1, right, and S2 are equal. It returns a positive value if S1 is lexicographically less than S2, and negative value if S1 is greater than S2. So in string to string comparison, there's lexicographical comparison. This is actually beyond the scope of this review, so we will get past it, but you will find lots of references online and in textbook as well that talks about these lexicographical, which governs the quality of the string instances in comparison. Of course, there are also other library functions that you can do, such as converting a string S right into a floating point number, which is a double, and that returns the result of that conversion. There's also A2I, which converts string S into an integer, right? So on and so forth. There are other utilities out there that we won't discuss. Lastly, there's another C header file, which is very useful. You can do pound include C type. Again, you can find references on c++.com and various different online resources looking into the API. This header files is part of the C standard library that declares many functions or routines that are useful for testing and mapping characters. So some of these utilities include, for example, some of the most popular ones like isDigit, right? And then you have, right, checking to see if this particular character is in digit or not. Or you can have isLower, right? Is upper, checking to see if that character itself is uppercase or lowercase. There's also checking to see if that character is a space. Is it not a digit, right? We can also have functions that convert the uppercase letter to lowercase, or function, which is what we call to lower, right? And then this actually takes that. So when I say integer C, it's the same as char C, right? There's also toOpper, right? That converts that particular characters into an uppercase. So on and so forth. The last topic I wanted to cover here is C string as a pointer. So if you look at A, B, and C, this is an array with a null terminator at the end. So this is called C right here. This C actually is a pointer, right? Pointing to the very first character of the array. So since C is a pointer, if we were to print out the value of C, this gives us a hexadecimal number. And we can actually test the theory by modifying this code here and see what happens. So this is what we're going to do. To print a pointer, we use a $P, right? P stands for pointer. And then if we print this out, C points to the very first element of the array. And this first element has this memory address, right? As you see here, it's a hexadecimal. Now, if we run this again, you'll notice that these values change every single time. And the reason is because every single time when we run it, we essentially stop the previous program, rerun it, and then your compiler goes into a particular space in memory at random, basically looking for this 4 contiguous bytes that are available in space to allocate. So this allocation happens at various different locations inside the stack, right? So they are never the same every single time. So that said, C points to the very first element of the array. If we use pointer arithmetics, we can actually dereference the C, right? Because it points to the very first element. When we dereference C, we indirectly get the value, right, at that location, which is A, out of it. And A is a character, so we use C here to represent it. And again, we can see that's the case. If we use pointer arithmetics, right, if we do a +1 here, this effectively jumps into the next memory location, which is 1 byte over. When we jump 1 byte or element over and dereference it, we should be getting the very next character, which is B, right? And then we can do the same thing with C, so on and so forth. When we do the third one, this very last one is actually null terminator. When you print out null, it doesn't have anything, right? So this tells you the 4th memory location is actually a null, right? When you see nothing here. And then this is obviously, if you want to use array indexing, you can directly, print these out, right? Using the bracket notations. So that's the same thing as if you're using a pointer manipulation or pointer arithmetics. So this concludes an overview of C string.